Hello, welcome to another session on Azure Open Source series. And today we have our able speaker, Latif Taiwo. Hi, Latif.
Hi, Roland.
How are you doing?
I'm fine. I'm good.
Trust you've had a productive week.
Yes, we thank God.
Oh, interesting, interesting. So today we'll be looking at files permission in Linux. So Latif is here to do justice to the topic, and I believe he has a load of information for us today, right?
Yes, sure. We're going to learn a lot about file permissions on Linux and how to change certain permissions on probably scripts and our files, and also access control lists on Linux.
So
So,
what should we be what should we be expecting at the end of this session?
so they should get their system up. They should log into their system and ensure that they are on a Linux system, be it Ubuntu or whatever, and they should get their IT materials also, and they should be expecting to know everything regarding file permissions and access control lists. And we'll also
Okay,
be working with Vim. I'll just go through Vim and a brief shortcut on how to use Vim because I may run a simple script.
oh, okay, thank you so much, Latif. So I believe there's a load of information waiting for us. So without further ado, we'll deep dive into the session. So Latif, the floor is yours.
All right. Welcome once again to this session on Linux file permissions. Today we'll be talking about file permissions, and it is very, very important that you know file permissions as a Linux user or a Linux system administrator, because you will need to know how to efficiently manage and secure your system, including files and directories. And we'll be working on several commands: the chmod command, the chown, and chgroup command also. I don't know if the audience can see my screen. All right. So this is file. So we will now be talking about the file permissions. To start with, this is a simple diagram showing you what file permission is on Linux. If you are to open a file, you will see and type the command ls-l. If you open a file and type the command ls-l, as shown in this slide, you will see the permissions on that file, including its user, the date it was created, and what have you, and the time. Now, if on the first column on the file, if you have a dash, you know that that is a file, a regular file. If it is D that you have there, it is a directory. And you may have other things there. Now, after that first alphabet or symbol, the next things that you have are for the user. The next 3 bits are for the user. The next 3 bits that follows are for group. Now the next 3 bits are for other people on the system. Now moving on. Then the next is links, as shown on my slide. Sorry, on this slide. So the next is links, and the next is the user that owns the file or the directory. Then what follows is the group that file belongs to, the group of the user that owns that file or directory. Then the next is the size. Then what follows is the date and time, and the next is the file name. So basically, that is a simple representation of a simple explanation of, or a diagrammatical explanation of the file system. And on this slide, we have several things which we'll be explaining, and I would like to open up my Ubuntu operating system. I want to share my slide. I want to share my Ubuntu screen. So we've talked about this slide. I mentioned what this slide is. I don't know if you can see my screen. Mr. Roland, can you see? Mr. Roland, can you see my Ubuntu screen? Ubuntu.
Hello.
I can hear you.
I can't see your Ubuntu screen, but I can see your main screen.
All right. What about now? Can you see my screen
Yes,
now?
I can.
Ubuntu.
Yes, I can.
Okay, let me try to make this bold, although it may be blurry because of some things. Oh, it's the same. So I want to go into my desktop. Now, if I run ls-l here, we can see the permissions on the users, on the files and directories on this directory, that is on my desktop directory. We can see that for the first file here named demo.txt, you can see the dash. That means that it is a regular file. It is a file, and we can see the permissions that the user have. The next thing, we can see the permissions that the group have, and the next 3 bits we can see the permission that other users on the system have. So the user have read-write permission, group read-write permission, and other users have just only read permission. And just this is just a link, just one link to the file. That is it. Now we have the user savvy, the group savvy. We have the file size. We have the month the file was created, which is July, the day and the time, and the name of the file. Now, but if we come down to this next one, we have that this is a directory. And we have the user permission as read, write, execute, the group permission as read, write, execute, and permission for every other user on the system as just read and execute. If you look at this last file here, we can see that it is also, the last directory here, it is owned by user savvy, which is the current user on the system, and it is the group owning that directory is the engineers group. This is the file size. Now, you can, if you want to see more information about a file or a directory, you can use what we call the start command. Though this is not in my slide, but I just want to show us. So if you type start demo.txt, you'll see a lot more information about the file. You can see the file name, the size, number of blocks, the device, UID, user ID, and so many other things. The last date it was modified, and the day we created it. Now, we can now move on to the next slide. So you can extend the attributes of a file to another user. That is giving permissions of that file to a different user, and that is one of the things we'll be doing today. So now I want to talk about the basics of binary and octal numbers. It is on my slide, and I believe you should be seeing my slide. So back then in school, for those of us that read computer science, computer engineering, and maybe other related courses, you would have learned the binary octal system, and or virtually everyone that passed through the school system know what binary is. Binary is simply a base 2 number system. It can only contain 0 and 1. So this is like the foundation of learning how file permissions work. For example, if I want to give a permission of read and execute only to a file, what permission can I use? Which octal number can I use to give that permission? So octal number is very simple to giving file permissions to system. So this is just a brief about octal number system. I don't want to go deep into it. And this is a diagram I got. So for the octal number representation. So this code here is simply called 421 code for octal number representation, that is base 8. So for 0 to give no permissions to, let's say, the group, it is represented in octal form as 000, and that's why you see dash 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 there. The next one, to give only execute permission, that is 001. That is the octal number you will use. To give only write permission 010 and so on. To give permission to read, write, and execute a file or a directory, you give 111. Okay, yes, it is represented here as 111. But if you want to now write it in your system that you want to give the permission, in essence, you give the permission of 777. 777 gives permission to the user, the group, and others. That is, it gives them read, write, and execute. Now, so this explains what I've talked about. The next slide also explains what I've talked about. Oh, sorry, I was sharing the wrong slide initially. So this is a slide I just finished explaining, and we'll have this. I've talked about this. So there's this there's an online tool which I will share with us. It's called the chmod calculator, but you don't really need to use it. I have never used it before, and I will never use it because it is very, very simple. If you understand octa number system, which I just explained, you don't have to use the chmod calculator. So, but I'll just share the link with us. So now, moving on. Mr. Roland, you can share the link to the chmod calculator to the audience, but it's not needed if you understand octa file permission very well. So now we'll briefly talk about symbolic file permissions, which I'll be using on my Ubuntu system. I believe we can see my Ubuntu system because I'm sharing my entire screen. So if, for instance, this demo.txt file, I want to add write permission to to other users on the system. Mr. Roland, please confirm if you can see my system and the audience can also see my Ubuntu VM. So I'll do this. I'll do chmod O plus W. We are giving write permissions to other users. Let me do this again. ls-l. And by the way, we have another command which is an alias for ls-l, which is ll. So this demo.txt file, I want to give write permissions to other users on the system. So I'll do chmod O plus X demo.txt. And if we do ll or ls-l again, we have that. We now have that. Sorry, I made a mistake. I wanted to give write permissions. It's write permissions that I'm giving. So let me remove that. So we can now see that other users on the system have write permissions to this file. Now, it is not advisable to give other users this write permission or even read permission in some cases, depending on how confidential or sensitive the file is. Now, that is simply symbolic representation. We can go further or do this. We can say chmod U plus X, comma, that is user group plus X, and we leave others as empty. That is, we are giving the user and the group, we are giving them execute permissions to demo.txt file. If I do ll, so we have this. You can see that. Now, moving on with my slide. I don't want to waste too much time there. What you enjoy more is using the octa system once you understand it. So On my slide, you can see several representation of how Octa file permission works. And we have here that we want to use the chown or chown command. For example, I have several users on this system. If I cut my etc/passwd file, I can see the users I have on this system. I have user Joy, I have user Tommy, and I have user Bio, I have user Faith. So let's assume that I want to grant the user Faith access to my demo.txt file. I'll do chown Faith demo.txt. I cannot do this operation because I'm not using sudo, because Faith is not the original user, the original owner of that file. So I'll use sudo and I'll type my password. So if I do ll again, we can see that Faith is now the owner of this file. And you know that Faith is not the currently logged in user. So that is that. We can do more. We can talk about changing the ownership of a directory. For example, this Linux class directory that I created here. If we cd into Linux class and check the content, it is empty. I can really create several files. I can do touch readme.md test.txt. So we can decide to, a quick command tip, if you want to go back one step to the initial directory you can do this. Either you use cd ... but I don't want to do that today because we've learned that you can use this cd and hyphen to go back to the initial directory. And if I want to come back to Linux class directory, I'll do that again, cd hyphen. I'm in my Linux class directory. So that's just a new command tip for us today. Now, I want to grant the user Faith permission to own the Linux class directory and every file inside it. I have to use sudo because Faith is not the currently logged in user on the system. I'll use sudo chown -R. Then I'll type my directory, Linux class. A missing operand. Oh, sorry. This should work. So the chown -R Linux class. Let's see who owns this file. This is a new command that we'll learn towards the end of this file. This is one of the access control list command. The commands used for creating access control. Get facl Linux Oh, sorry, I am in the directory already, so I have to go back one step. So if I do sudo chown-R Linux class, it's still not working. Now I want to do get facl Linux _. Alright, so when I made a mistake, I did not specify the user Faith. It is sudo chown, change the owner -R to Faith for this directory. So we do ll for we do LL here, we can see that Faith is now the owner of this directory. And we can confirm that with the get facl command. You can do get facl Linux class. You can see that this is the owner, the group is Savvy, and we have that. So I'll briefly use this opportunity to explain this access control file permissions, access control lists. If I want to exclusively grant access to a file or a directory, I can do set facl. If, for example, I want to change the owner, I want to give certain permissions to this user, I can do set facl. I probably remember this command, but it's in our slide towards the end. So let's just move on with what we have currently. For the question, can we create more than one owner? I'll answer that question towards the end, but simply that is essence of groups. You add that owner to the group that owns that file. So that is just a brief answer to that question. So we have the chgrp command. The chgrp command, just as the name indicates, is the command used to change the group of a file or a directory. As shown on my slide. So I have several groups on my system. To know all the groups I have on my system, I can cat a file that is located in the etc directory. I can do cat /etc/group. So we have a group for engineers. We have group bio, group Chuka, group Faith. If you understand Linux systems very well, you know that if a user is created, automatically a group having the same name as the name of that user will be created. So that is why we have some of these groups here. So we can decide to change the group ownership of a file to this engineers group or another group. So now I want to change the group of the file demo.txt to be owned by the engineers group. So I'll do ch group engineers demo.txt. So I will know that I will see that this field, which stands for the Savvy group, will change if I to check using the ll command or ls-l command. So I have to use sudo. So if I do ll, you can see that we have engineers. So back to that other question, if you now want several people to have this file rather, you can now add those users to this engineers group. So I can add user Faith to engineers group using a command uh, is a group add. Let's move on. Now we can use we can change permissions to execute scripts. As shown on this slide. So briefly, I'll open the Vim editor. Let's say Vim, I want to create a new file. Let's call it script.sh. So Vim is not installed because this is a new system, a new installation of Ubuntu. I'll install it using sudo apt-y vim. Alright, vi sudo apt install. Sorry. So while this is installing, I can install another tool. Okay, I have some errors here. I think Vim should be up. Vim. Let me try to update my system first. Sudo apt update and sudo apt upgrade. I didn't type my hand correctly. I'll open a new command and explain some things. So sudo apt update and sudo apt upgrade. This command updates the system, the first part of the command, and the second command upgrades the system. But if this first command fails, the second one will not run. So if you want the second command to run, irrespective of what happens to the first command, there's a way to do that. A new Linux tip for you today. You type this, you do sudo apt update, then you type semicolon sudo apt upgrade. So if the first command fails, it will go ahead and run the second command. So that is a brief tip for you. While I'm working on this installation, the update is not done, so I can't install Vim, but you can use nano. So nano script.sh. So I'll quickly do this. I'll create a bash script. So this is just a simple basic bash script for you. So we are touching bash script today. Type /hash/bin/sh. This is called shebang, and that is what starts every Linux command, every bash script rather. So I want to say echo hello world, and I'll redirect the output to demo by appending it, by doing an append to demo.txt. So I'll close this and I'll save. So we have this bash script. So to execute this bash script, you use chmod plus X. You have the execute permission script.sh. So if you want to now execute it, we type ./script.sh. I think I made a mistake in my script /bin/bash. So it threw that error because there's no sh shell on this system, but there are several shells. We have the Z shell, the fish shell, and the likes. Why is the name of my script changing? Never mind. Permission denied. For some reasons, my script is not running and the name of the file is changing. I guess this update is messing up my system, but we'll still move on. Now, the next thing we'll have here is file permissions in practice. I think I've mentioned that. So we'll move to using. All right, this is a simple scenario for under file permissions in practice. It's talking about a simple scenario where you want to grant I've done this. We want to grant total exclusive ownership to the leader of a team, exclusive ownership to a file, to a directory rather, exclusive ownership to a directory to the leader of a team. So that is when you use this command. So we can do a lot of things. We can change the permission on our demo.txt file. Let's say we want to grant the owners only. Sorry, let's say this will give the user execute. This will give you read and execute permission, and 4 will give others only permission. So we do demo.txt. So you can see that here. So there's another command or another way to grant permission. This command here where I have user mod -ag web dev and dev1 is changing the permission on this directory, or it can be a file, such that it is adding a secondary group called dev1. is adding that file or directory to a secondary group called dev1. So we'll put that into practice now. If assuming this dash G here is user mode is for user. Let's say I want to add the user. Um, Toby or Tommy rather, to a secondary group of engineers. Sorry. So the group should come first, then the name of the user. I know that I have a user called Tommy here. So that has been added. If I want to confirm that, I can cat /etc slash my pass wd directory. It's not displaying here. So that basically adds the user Tommy to the engineers group. Let me cut my groups first. Okay, I can log in as user Tommy. Yes, let's see, sudo switch user Tommy. So, and if I am to list the groups that Tommy belongs to, we can see that Tommy belongs to a group called Tommy and another group called engineers. So if we have any question, let's quickly drop a question here. Mr. Roland, let's quickly drop a question and I'll be back in a minute. to the group. For example, we can change the ownership of the directory webdev slash specific underscore dir to the group webdev. And then we can now use the chmod command to give that permission, to give permission 775 to the directory. So we can put that into practice using one of our directories. So if I have ch group, sudo ch group, let's just use ch group because this user belongs to the group I want to work on. Ch group -r, and I have a directory linux underscore class ch group -r group user, I think I have a user called Chuka on this system. Then I'm granting him access to this. So in an organizational setting or in a live setting, you may want to grant, you may want a particular user to have access to a particular file, let's say on your server. Then you have to change certain permissions. So we have this group. Sorry, this should be engineers, or I just create another group, but let's still use engineers group. So I'll use sudo. Now I want to give the user Chuka read, write, execute permission to this file linux underscore class. Okay, I think I don't have that user. I'll give the user Tommy. Search file directory, sorry. chmod sudo chmod -r 775 to linux class. So since the directory as since users in the group, since the group engineers have exclusive access to that directory, they will now have 775, they will now have that permission to read, write, and execute because we gave the group read, write, execute permission. So now I want to talk about regular maintenance. We want to talk about regular maintenance and security best practices. So you should keep the following in mind. Limit permissions, that is, use or employ the least privilege principle of least privilege. Do not grant more than the kind of permission that the user needs to that user. Grant only permission that the user needs. So don't grant him more than what he needs. Also, use sudo sparingly. Don't always use sudo, except you need to use it exclusively. You can protect sensitive files by using permission, let's say 600 That is, you give only the user read and write access, but no execution access. Then you do not give group any access, any permission rather, and you don't give other users any permission. So now we want to talk about SUID and SGID, that is special permissions, special file permissions. So alongside the basic read, write, and execute permission, Linux also provides a set of special permissions known as SUID, SGID, and sticky bit, which is set user ID, set group ID, and also sticky bit. So for set user ID, the set user ID on the file allows the file to be executed with permissions of the file owners, of the file's owner. It is particularly useful for executable programs that need higher permissions to run. So if another user, if you want to allow another user to execute a file with the permissions of the original owner of that file, you can use what we call the SUID, and that can be done using this command. So you will do this. We say chmod u plus s. Then we specify the file name. Or in octa format, you use chmod 4755, then the file name. So I'll put that to practice here. Let me quickly create another file. Or let's say ll linux class. So I have readme.txt and text.txt. So we can do chmod u plus s. U stands for user and s stands for set uid. So I'll have to readme.txt. I think I made a mistake in that file. Readme.md. It's not in this directory, so I'll specify the directory linux class /readme.txt. Sorry, I think I made a mistake there. Let me just clear my screen. I'll do chmod u plus s so I have to use sudo here. So if I now do ll linux class /readme.md, so we can now see that there's an s here under the execute bit. So from what I said that SUID will allow other user to execute a file with the permissions of the owner of that file. So SUID bit is set here, and that's why you can see that we have this S in the execute bit session for the user. So if we want to grant that on, let's say, another file, let's say we have, let me see what files we have here. We now want to grant SUID permission using the octa bit. We use the digit 4. 4755. So basically, what permission was here initially? It is 775 rather. So I will do 4775. So this will grant this will set the SUID bit on that file. So if I do LL, so we can see that the SUID bit is set. So there's also something called SGID, and the SGID bit is for group. That is set group ID. The SGID bit, when it is set, it allows the file to be executed with the permissions of the group owner. So if it is set on the directory, it ensures that new files created within the directory inherit their group from the directory, not the user that created the file. So to set SGID permission, you use chmod g+s using the symbolic notation, then you specify the file name or the directory name. Or using octal notation, you do chmod 2754 or what other permissions you want to give the file or the group. So we will now set group ID on our Linux class directory. So I will do chmod u plus g plus s, that is set group ID Linux underscore class. So if I do this, I can see that in my Linux underscore class directory, I have the set the execute permission of the group becomes S. So we can actually do this on our demo.txt file. Let's do this on our demo.txt file using the octal permission. We'll do chmod 2 is for setgid. Don't forget 2 is for setgid and 4 is for setuid. 2754 demo.txt. So if I run this command under this execute permission, we should see S. So I will use sudo, and if I do ll, let's just do this grep ll5 grep demo. So we have that the SGID bit is set for this file. So that is SGID for you. Now sticky bit. Sticky bit, when it is set on the directory, prevents users from deleting files in that directory. That is files in that directory that they don't own. It prevents user from deleting them. Sticky bit is very, very useful for shared directories. So how do we set sticky bit? We just add +T using the chmod command, we do chmod plus t, then the directory name. Or in octal notation, chmod 1, then the other permissions we want to give to the directory, then the directory name. So don't forget, 1 is for sticky bit, 2 is for sgid, and 4 is for suid. So, and I have a diagram, a simple diagram explaining SUID and SGID permission, just a diagrammatical representation of the bits that will be set there. So now I want to set I want to set sticky bit on my Linux class directory. I'll do chmod plus t Linux class. So if I do ll by grep Linux so we can see T, yeah, so that means that SGID bit is set for that directory, and that will prevent users that don't own file in that directory from deleting those files. So in octal notation, it is chmod 1775. That's you now specify the permissions you want to give that directory, and you will see that there will be T will be on the execute portion of the other permission on the file. So SUID is for user, SGID is for set group ID, and sticky bit allows you it allows you to prevent other users from deleting files that they don't own in a directory. So to wrap up, we'll talk about file access control lists, which I made mention of initially, and I used the get facl command. So access control lists allow you to manage the access that that users have to files and directories, and you can try to check the access control list on a file or a directory using the get facl command, which I've done before. But let's do that once again on our Linux class directory. I'll use get facl Linux class, and we can see that we can see the file name, the owner is Faith, the group is engineers, the flags, we have SUID flag set, and we also have SGID flag set. Yes, this is SGID. Dash here means that there is no SUID bit set. Assuming SUID bit is set, this dash here should be S. So we have SGID bit set and we have sticky bit set. So let's quickly set SUID bit for the Linux class directory and run the get facl command on it. That will verify that under flags here, this first bit will change from dash, from hyphen to S. So we'll do sudo chmod u plus s Linux class, and if I run get facl again, we can see that we have S here under the user set UID flag. So SUID flag is set user identity flag is set SGID is set, and also sticky bit is set. Then you have the permissions of the user as read write execute, permission of the group as read write execute, and we have permission of other users as read and execute only. Now to now use access control lists on a file or a directory, you use the set facl command. So this set facl command that is shown on my current slide, the set facl command is used in this way. You do type set facl dash m or dash dash modifier. Dash m here means modify. You can use dash m or dash dash modify u colon the username colon the permissions you want to give, then colon and then the file name or the directory name. Now let's do that on our Linux class directory. I'll do set facl um, dash m u. I want to change the user back to Savvy, or Savvy that owns that file initially. Colon. I'll give uh, I'll give that Savvy you read write execute permission, and I'll type so I have to use sudo. So if I run set get facl again, you can see that Savvy is now the owner of that file. So with this, we've come to the end of today's class. If you have any question, let's ask. Roland, we have come to the end of today's class. So the audience can ask questions, and let's round up.
Hi, Savi.
Hi, Roland.
Okay, thank you so much for the session. I don't think we have any question. I'm looking through the chat window now, so I can't see any question.
Yeah, the question they have answered it
Yeah,
while I
so
was
that was the
taking the
only
session.
question that we had earlier. So I believe we've not concluded this session, right? So hopefully we get to continue from where we stop next week.
Yes, we're moving to another topic next week.
Okay. So thank you so much for taking out your time to share the information that you have with our audience. On behalf of the community, on behalf of the Microsoft community, we really appreciate your time and effort. And to our online audience, we believe this information you've gotten will be useful in your career. So this is a series. If you've missed any of our previous session, please take time to go back and watch the recordings. We have everything available to you on YouTube channel. So if you've not subscribed to our YouTube channel, please kindly do so. Follow us on all our social media platforms. We are available on LinkedIn, we're on Twitter. So follow Azure Nigeria Community User Group on LinkedIn and Twitter.